Everyone, today's topic is diazomethane part 1. So in this what we'll study is we'll study the introduction preparation mechanism as well as certain applications. So moving on to introduction, what do you mean by diazomethane? Diazomethane is also represented as CH2N2. It is an yellow gas. It is highly toxic and explosive if and we will not use in the industrial also. So it has also been stored as an ethereal solution and as diethyl ether at 0 degrees Celsius. It has the resonance hybrid of the following canonical structures. So if you will see the diazomethane structure, that is your CH2N2, CH2 double bond N, double bond N, and here you are having the positive charge because it and nitrogen atom is gaining the 4 bonds and nitrogen atom losing the nitrogen is having only 2 bonds. Because of that it is having the minus charge. When you will do the resonance structure of this, what happens here is this negative charge will move and it will make it as a bond, and then this bond will shift and make it as your carbon ion. Once you will get the carbon ion, and when it neutralizes when this bond neutralizes the positive charge of the nitrogen atom, it will make the another resonating structure generating you as the carbocation. Okay, then moving on to preparation, here is the preparation. So in the preparation there you have to study by the two steps. First, in general I will tell you without representing your R group. R group can any of your or methyl alkyl groups, that is your methyl, ethyl, propyl, etc. So here if you will study in the preparation, it has how it is diazomethane is prepared is by the decomposition of various derivatives of N-methyl N-nitrosamine. And first we are taking the N-methyl N-nitrosamine, we are treating it with the base S, and by the first you have to tautomerize it, and after that diazoesters are formed, leading to the elimination reaction with the base by the formation of your diazomethane. So if you will see in the reaction preparation, you are taking the N-methyl and N-methyl and nitrosamine, and then if you will treat it with the base such as NaOH in presence of ether, you will get diazomethane with the elimination of one of your sodium carboxylate and the water. In the mechanism, if you will see, you are taking the N-methyl and nitrosoacetamide, and then if you will see here, see that R group is represented by the CH3. You are replacing the R group by taking the methyl group as your or alkyl group. So if you will see here, this nitroso group is having the negative charge. This oxygen is having a negative charge, and that you have studied that tautomerization and enolates. So what happens here is this oxygen atom, the whole of the oxygen atom will shift over here. That is the rearrangement which is taking over here. Oxygen atom shifts to the carbonyl carbon and it goes and attacks, and this single bond between the C and N, that will shift to the N and N single bond, and it makes the double bond. After rearranging this, it gives you methane diazoacetate, that is your diazoester. Once the diazoester is formed, at that time you have to synthesize your product. So there is the attack of the base. NaOH will act as your base. Sodium will be sitting over there, and then the OH minus will go abstract the proton on from your CH3. One of the H atom from your CH3 has been abstracted, and once it gets abstracted, there is the removal of your water molecule. Okay, the water molecule gets removed out, and then the bond which is present between the CH2 and H atom will shift, and then meanwhile the electrons, the lone pair of electrons which is present in the nitrogen atom will also shift, make a new bond. The already present existing bond which was there, that will shift towards the next nitrogen atom. It will convert into charge, and there is the elimination of your or acetate ion. Okay, the cleavage between the nitrogen and the oxygen atom, this bond will shift, make a charge, that is O minus. Then you will have CH3COO minus, the salt which is there like Na plus metal, which will go and attack, and that will give you your sodium acetate and diazomethane with the elimination of your water molecule. In the application part, there are two reactions in the diazomethane: reaction in which the nitrogen is lost and the reaction in which nitrogen is gained. So moving on to reaction in which nitrogen is lost, so here you are studying the certain reactions. So if you will take, in presence of diazomethane, if you will react with the hydrogen halides, you are forming the alkyl halides have been formed. So you are taking the hydrogen halides can vary, like X group can either be in chlorine, fluorine, bromine, etc., and so on, any of the halides. And then you are taking the diazomethane. So diazomethane, the carbon atom is having the minus charge in the diazomethane. Diazo is for two molecules of your nitrogen atoms. Okay, azo compounds is for your nitrogen atoms. Methane is your from, if you will take the CH4 and then two of the hydrogen atoms, if you will replace with the nitrogen atom, it is called as diazomethane. So here it is having a negative charge, that will go and abstract the proton on, and then when it abstracts the proton, there is a removal of the halogen atom. As a good living group, it will cleave out, and after that you are generating the methyl azide. Once your methyl azide is formed, at that time the X minus, which is your halide which has been cleaved out, that will go and attack to your alkyl group with the evolution of your nitrogen gas, with the liberation of your nitrogen gas. That is, your nitrogen molecule has been lost, it is no more gained. In this reaction, you are telling, your main focus is that the nitrogen has been lost if you are doing this reaction. So you are getting the alkyl halides, that is your methyl halide. In the methylation of the carboxylic acids or esterification of carboxylic acids, if you will study this in the esterification reaction, you know that in general what we'll do is, you will take the carboxylic acid and then you will treat it with the alcohol, for that is your esterification, an ester will be formed. So here what happens here is, instead of that alcohol, you are using the diazomethane. So diazomethane is having the CH2 minus, right? So that minus charge, again carbanion will go and abstract the proton from the carboxylic acid, one that is very acidic in nature. The carboxylic acid proton is acidic in nature. It will abstract that proton, and the bond which is present between the oxygen and hydrogen of the carboxylic acid, this bond will shift, make a charge by the cleavage of your carboxylate ion and the diazonium salt. Once your diazonium salt is formed, then there is the attack of the carboxylate ion charge to the alkyl group. So the oxygen atom O minus will go and attack to the alkyl group by the elimination of the nitrogen molecule. That is, your nitrogen is again lost by the formation of your ester. Then moving on to methylation of phenols and other compounds. Here the phenols you are taking. Okay, so phenols, you know, this is the structure. So here again you are having the OH. And then in presence of CH2 methane, you will generate the anisole. How you will do is, same thing, instead of carboxylic acid you are taking the phenol. So this phenol hydrogen which is present over here, first the CH2 minus will go and abstract that proton, and then you will generate the phenoxide ion. Once the phenoxide ion gets generated, at that time the diazonium salt which will be present, okay, that diazonium salt, the attack of that phenoxide ion to the alkyl group of your diazonium salt, and after that, with the elimination of your nitrogen atom, you will get back your anisole. That is, if you will see here, there is an ester formation. Anisole is nothing but the benzene ring attached with the OCH3. The next point is the phosphoric, how you will convert the phosphoric acid to phosphoric ester in presence of diazomethane. So if you will take the diazomethane and then if you will treat it with the phosphoric acid, again same mechanism will take place, like CH2 minus of the carbanion will go and to the hydrogen atom, that is, it is methylating it. Once it will go and attack, at that time what happens, again there is a formation of one of the salt, diazonium salt, and the generation of the phosphorate ion. The phosphorate ion again goes and attack to the methyl group with the elimination of your nitrogen atom, generating you as the phosphoric ester. Thank you. If you have any doubts, you can ask me in the comment box.